So what we're looking at today is the final lesson that is broken into two parts. We do part one today, part two tomorrow. Once again, Wednesday and Thursday of this week will be review, and your unit exam in logarithms and exponents will be Friday. We're solving exponential equations today, but we're solving them where a common base is not possible. So if you have 9 to the 3x plus 1 equals, doesn't matter, 27 to the x plus 8, this is a type of question that I gave you on a quiz last week. Right? There's a common base, and let me warn you right now. What we're going to learn today is not to be used, in my mind, to solve this equation. Can you solve this equation that I've got written down using what we learned today? Yes, but it's more trouble than it's worth. It becomes nightmarish. So all you do here is say that 9 is 3 squared in base 3. 27 is 3 cubed in base 3. These are each powers of powers. So I'm going to multiply these exponents, which is the rule for what we call a power of a power. I'm going to multiply these exponents. So, 8. I'm going to multiply these exponents, and then I feel as though I shouldn't even really need to finish solving this. If the bases are the same, the exponents must be the same. So that means 6x plus 2 is equal to 3x plus 24, and you solve it. It doesn't matter. You're going to get 22 over 3, I believe. Subtract 3x from both sides. Subtract 2 from both sides. So you get x equals 22 over 3. So once again, because very often on an exam I will give a written response, a little written response question that says solve something like this, and people start doing what we learned today, and boy, it gets really, really messy. If that were the equation, then you have to do what we do today. You could solve it graphically, but we're looking at an algebraic approach. So we're going to be using logarithms today and tomorrow to solve all kinds of equations algebraically, but today it's going to be exponential. So the question is, what is x if 4 to the x is 605? And I realize that some of you will know what x is by looking at this, strangely enough. But I don't, if you automatically know what x is, I don't want you to do it that way. Okay? What we're going to do, and you need to focus your attention up here, is take the logarithm of both sides. And we usually use the base 10 logarithm, although you don't have to. The reason we use the base 10 logarithm is at some point, if we want to figure out what the answer is in decimal form, we can go to our calculator and we can enter it. Can anybody figure out why we would do this? There's a reason why you do things to equations. It's to make the equations easier. In what way is taking the logarithm of both sides here making this equation easier to solve? Jay? We can bring the x down, and now guess what? We do not have, that's exactly right, we no longer have an exponential equation. We've got a linear equation. This is no different in principle from 12x equals 117. What this is, and I know you know this, but I feel the need to say this, this is just a number. That's all log of 4 is. It's some number. You know, what is this? This is just a number. It's a different number. But these two things are simply numbers. So how do we get x by itself? We take the number on the right-hand side and divide by the number on the left-hand side. And we get x equals log of 605 over log of 4. And there's nothing you can do to simplify that because there's no rule for a logarithm divided by a logarithm. There's a rule for a logarithm of something divided by something, but not for the division of two logarithms. Any questions with that solution? Is there anybody who looked at this and said, well, if I convert it to exponential form, then x is log base 4 of 605? Because if you did, I'm here to tell you it's not always going to be that simple. You can't do that. By the way, log of 605, log base 4 of 605, using the change of base formula, is that, which is what we got. And I would probably say to you that this question is merely a warm-up to what we would be expected to do on exams. I'm not going to give you that as an exam question. So if you look at this one and you think you can just rewrite it in exponential form or in logarithmic form to get an answer, it's not going to work. So the first thing we want to do is ask ourselves, can I divide 568 by 8? So we have 8. This is multiplied by 3 to the 2x. This is equal to 568. I would much rather take the logarithm of both sides after I divide by 8, as long as I don't have fractions. So does 568 divide by 8 without remainder? And the answer is yes, 71 times. So if you start by dividing both sides by 8, this becomes a lot simpler. We're left with 3 to the 2x equals 71. And now we can take the log of both sides. Once again, could you write that in logarithmic form? Yeah, you could, but I don't want you doing that because, I mean, if you try to do this one by writing it in logarithmic form, there is no logarithmic form. Well, there is, but it's the wrong path. Forget about it. I mean, it just won't work. I'm trying to teach you what will always work. So now we're going to take the log of both sides. This is log base 10 of 3 to the 2x equals log base 10 of 71. Probably, again, everybody, this is what you would see on an exam, but I prefer you putting brackets around here. And it's because of that conversation we had about that logarithm being squared. You need to understand that if the argument has the exponent, you can move the exponent down. And that means the exponent has to be in brackets. So this becomes 2x log 3 equals log 71. So I need to divide both sides by the 2 and the log 3. In fact, and I don't know that it's necessary, but this line is the same as writing 2 log 3 multiplied by x equals log 71. So you can see what's happening here. I'm dividing by 2 log 3. And that's the answer, except it probably wouldn't be written that way. It would be written as log of 71 over log of 9. And I mean, I'm hoping everybody's at the point when you see 2 log 3, you're at the point where you say that's log 9. Because 2 log 3 is equal to log of 3 to the 2, which is log of 9. Which brings up an interesting idea. Right here, when I brought that 2x down, I could have just brought the x down and left the 2 up there. Let's go back here, though, because I believe it probably said solve each equation for x. We have done that, and I don't want you to get the wrong impression. You have to know how to get an exact value. But in this set of questions, we're also finding a decimal approximation. So we can take log of 605 divided by log of 4 and get that as an answer to A. Interesting, now that I've just introduced you to the natural logarithm, ln, what would have happened if you took ln of 605 divided by ln of 4? Well, you get the same answer. That would just mean you started off by taking the natural logarithm of everything. Anyway, about 4.62 or 4.6 over here, log of 71 over log of 9. Gives me this. So about 1.9. I'm going to put something into my calculator right now. There's the answer. I'm going to put something into my calculator right now and ask you what I've done wrong. Why is that wrong? Alex?
You're dividing by 2 and then multiplying by...
Right, I'm dividing by 2 and then multiplying by the logarithm. So when you take a look at the correct answer, I've got log of 71 over log of 9. What this is, which is not correct, I've got log of 71 over 2 times log of 9. So you could certainly do it this way, but you would need brackets around the 2 log 9. Or go divided by 2, divided by log 3, not 9. All right, those brackets are important. Let's try another one. Well, we're getting there. This is an exam style question now, definitely. I need to take the logarithm of both sides. See, it looks nice, and I know you get it, but I want those brackets. I never used to put them, and then I realized that when I get students to put it, they make fewer mistakes. So, learn from my experience. So I take the logarithm of both sides. I'm double checking to make sure everything is correct. Now I'm going to swing the exponent down in front. And ask what I did wrong this time. Shira? Around what? The coefficient. Right? This exponent of 2x minus 1, the entire exponent has to be multiplied by log 4. And this exponent of x plus 2, when I swing it down, that entire exponent, which now is a coefficient, that's the right word, is multiplied by log of 3. Now, there's kind of 2 to 3 steps involved in getting x by itself here. And some of you will be stumped here. Even after doing this many times, you'll forget what this first step is. What I can tell you is that when you solve any equation, you want to get your x's on one side and your numbers on the other, right? But you can't do that right now because your x's and numbers are packed together in those brackets. It's 2x minus 1. They're locked together. So hopefully that will trigger the idea that you need to multiply this out so that you have x terms and you have number terms. So I need to multiply this in, and I need to multiply this in. I got to make a mess of it before I clean it up. So I'm going to get 2x log 4 minus 1 log 4. And that 1 isn't necessary. And then x log 3 plus 2 log 3. I just want to double check all of that. 2x log 4 minus 1 log 4 equals x log 3 plus 2 log 3. It looks good. By the way, this 2 log 3, you can feel free at any point in time to write it as log 9. I'm not going to just yet. So then the next step most people understand what you have to do. You have to move the x's to one side and the non-x's to the other. And I've always been of the philosophy that you want as few negatives as possible. So, for example, if I decided to move my x's over here on this side, then both of my numbers, both of my non-x terms would be negative, and I would have another negative x term. I think it's more economical with negatives, or lack of them, to do this. There's a lot of stuff floating around in here. X's, numbers, logs, numbers. Just double check everything to make sure it looks okay. 2x log 4 minus x log 3 equals 2 log 3 plus log 4. Looks okay? Okay. So now this is the second stumbling point. You look here and you go, okay, well, oh, right, I remember. I got to expand it out to expose all of the x's as individual terms. But then people get here and they go, well, how do I get x by itself? Who can tell me? Because you don't, before I get to your suggestion, you don't normally have something like this. Like, imagine that it just said, I'm going to cover something up here. And change the question just slightly. Imagine that it was that. 12x minus 7, you'd say 5x, wouldn't you? But that doesn't work here because of those pesky logarithms. And I'm not asking you to think that way. There's a more direct way, Ashira, do you know? That's exactly what you should do. Factor the x out so you get a single x and then numbers everywhere else. So if I factor this x out, I'm left with 2 log 4 minus log 3. And, by the way, that 2 log 4, you can feel free at any point to write log 16 because that 2 can go up. And, you know, along the same lines as what we talked about before, I don't know if it was in this lesson or an example from yesterday, from last class, this is just a number, right? This is just some other number. So you have x times a number equals another number. Just divide by whatever x is being multiplied by, and you have your answer. So x will be equal to 2 log 3 plus log 4 over 2 log 4 minus log 3. Or, so this is a legitimate answer, or log 9 plus log 4 over log 16 minus log 3. You okay with the move and tumbling that through with the exponent rule, the power rule? Or, because you've come this far, why not? Log of 36 over log of 16 minus log of 3. Because log of 9 times, log of 9 plus log of 4 is log of 9 times 4. Could you write log of 36 over log of 16 thirds? Yes, but I would say why? Why introduce a complex fraction when you don't need to? So had the 16 been divisible by 3, like maybe it was 16, log 16 minus log 2, by all means divide them. And if we want a decimal answer, we can, I'll go with this one in the center of the screen. log of 36 divided by, actually I'm tempted to go with the bottom one because then I can just enter it quicker, but that's okay. Brackets, log of 16 minus log of 3. That's about 2.1. Any questions with C? D is the beast of all of these. And it's because if we go back and look at B, by the way, we could get rid of that coefficient of the power. We could divide both sides by 8. But if I do that kind of thing here, all I do is this. And I'm just moving my problem to another location. I can't get rid of that 24. So I'm going to take the logarithm of both sides. So I can move this exponent down over here and write x plus 3 log of 2. Why can I not move that exponent of x plus 2 on the left side out in front? Do you know?
Because it'll multiply by 24.
Pardon me?
Because it'll get multiplied by 24 if you move it out.
Yeah, it has something to do with that 24. This thing here, log of 24 times 6 to the x plus 2, doesn't match that log of m to the n. Does anybody know what we have to do first?
Would you break it up into log of 24 plus log of...
Excellent. We're going to have to break it up into log of 24 plus log of 6 to the x plus 2. Now we can move that down. So we have log of 24 plus x plus 2 log of 6 equals x plus 3 log of 2. Okay, well, we got to expose those x's. They're trapped inside with those numbers. We want to distinguish between x's and numbers, so you have to expand this out and get log of 24 plus x log 6 plus 2 log 6 equals x log 2 plus 3 log 2. Just double check everything. So just in case you don't see it, this is what's happening. You can feel free at some point to change the 2 log 6 to log of 36, and listen carefully, to change the 3 log 2 to log of 8. Not 9, 8, because 2 to the 3 is 8. The rest of the problem is not difficult as long as you double check all your numbers. You need to move the terms with x to one side and the terms without to the other side, factor the x out, and divide. I think it will be less negative overall if we move the x's to the right and the non-x terms to the left. Log 24, 2 log 6, negative 3 log 2, x log 2 minus x log 6. So it's kind of interesting to just pause sometimes in this course and try to take yourself back 3 months to before the school year started. and me to tell you, or past you, this is stuff you're going to be doing, right? You're learning some pretty heavy duty math here. So we're going to factor the x out. Why not? Let's just move those exponents up here. You can move them up later. If you didn't move them up already, you can move them up later. And that means that x will be equal to log of 24 plus log of 36 minus log of 8 over log of 2 minus log of 6. I want to say a couple things about our answer here. And I don't care about the decimal form. If you want to spend some time calculating this, you do need to know how to calculate it. But I would calculate the top and the bottom separately and divide them. But the important points I want to make is, do you remember at the top I said let's move all the x's to the right? Had you decided to go the other way, then you would have gotten the following. I did that this morning too. That's an x, not a 0. Then you would have done the following. You would have moved everything to the other side, and what would have happened is you would have got negative here, positive here, negative here, and positive there. The last thing I want to note, and I'm looking, can I erase this last line? I'm just pointing out that everything would be opposite. Okay. The last thing I want to point out is if you pack together the numerator, it will be 24 times 36 over 8. Does this number work together to give us a whole number? And I think the answer is yes. I think it's 108. So there's utility, there's usefulness in doing this, because if you do want to find it as a decimal form, it's a lot easier to multiply 24 by 36 and divide by 8 and do a single logarithm. Could you write that? Yes, there's nothing wrong with doing that, because log of 2 minus log of 6 is log of 2 over 6. So if you want to figure out a decimal form, feel free. Any questions with that final example in question 1? All right. I want to, well, let's read this question, and then I'm going to change it. I'm going to change what the question is actually asking, and you'll see why in a second. So the following shows the mass of a radioactive isotope that remains at 2 different times of the day. So at 9 a.m., there's 150, we'll call it grams. It's a new question, so it needs a bit of work. New question in my notes. And at 1 p.m., there's 75 grams. Okay? And what I want to ask instead, we can certainly answer the question I've asked, but that's not what I meant to put in here. When will the mass be $57 grams? I better not go with 57. 58 grams. But what time is the mass going to be 58 grams? So this is an application of exponential growth and decay. It's y equals a times b to the t over p. The initial amount is 150. The base, because it's exponential decay, is 0.5. So far this is identical to stuff we've already done. In fact, as well, finding p, which is the half-life, which is the time it takes for half of it to be left, even though I might not have asked this in a question before, you can do that. What is the half-life? 4 hours. And this, I think I had mentioned this. I've seen this on diploma exams recently, like the past 3 or 4, so I thought I'd include something similar. You start off at 150, and then they give you the 75 grams left, which is exactly half. So how many hours is it from 9 till 1? 9, 10, 11, 12, 1. 4 hours. So the period of having is 4. We want y to be 58. So how do we solve this? Well, when we first learned of these applications, we solved them graphically. Here we're going to solve it algebraically because it could be a written response. So I'm going to take the logarithm of both sides. Well, no, I'm not. It'll be wiser if I divide both sides by 150 first. Because if I take the log of this right now, if I take the logarithm of this, the base 10 log, then I'm going to have to write log of 150 plus something. So I'm going to divide instead 58 over 150 equals 0.5 to the t over 4. If you've been following the lesson so far, this is not a difficult equation to solve. I'm going to take the log of both sides. Rather than calculate what it is in decimal form for the 58 over 75 or over 150, I think it's 29 over 75. I'm just going to write that. This is equal to, now how many of you would just write it's equal to t over 4 log 0.5? Okay, that's fine, but don't do that on a written response. Show that you are writing the log of 0.5 to the t over 4. Child's play from here, because the things that I'm going to highlight are just numbers crowding around the thing we want to find. So to get rid of the divided by 4, you're going to multiply by 4. To get rid of the log 0.5, you're going to divide by log 0.5. So t will be equal to 4 log of 29/75 over log 0.5. There's absolutely zero profit in it, mathematically speaking, for you to start using laws of logarithms here to change the appearance of the answer. We want a decimal. That's what we want. But you want to show your work up to that point as being algebraic. So just the way my brain works, I would probably do this. Multiply by 4. Divide by, don't let that negative scare you, because the log of 0.5 is going to be a negative number. It started at 9. So 5.48 hours, so about 5.5 hours past 9. 10, 11, 12, 1, 2, about 2:30. So the number of hours, the answer to this question is 5.5 hours after 9 a.m.